You identified a salt water solution as redox signaling molecules and helped stabilize those molecules so that they could, for the first time, become commercially available more than a decade ago. Since then, lots of grants have been awarded to universities to study redox biochemistry. Tens of thousands of scientific articles and numerous books on the subject have been published. From all of this, what major advances have been made? And can you help explain in layman's terms what is new and what have you learned about redox signaling molecules over the past decade?
That's quite a question. And thank you very much, Amy. The field of redox signaling is almost as broad as the field of life itself, the field of biology. The field of redox biology, of course, has been of great interest, as well as cellular signaling has been of great interest just because of the broad applications that we have in such fields. So if I could I give a little overview of what redox signaling is on the atomic level, and then we can discuss maybe some of the science or the new science that has come forward in the last decade, as you asked. So I have a few slides that I prepared. I'm going to share my screen. As many of you know, most of the root cause of disease is inflammation. Inflammation is either at the cause of the disease or it is a result of disease. Whenever we have an allergy, asthma, diabetes, any type of tissue that's in stress, we also have the accompanying inflammation. So, to understand redox signaling, really, we have to go right to the source. What do the cells do when they become damaged or harmed? And this is very common for everybody. If a foreign object gets in you, or you have excessive fat, sugar, or hormonal imbalance, if you're mentally or emotionally stressed, you can feel what they call oxidative stress or inflammation. This is manifest by swelling, pain, warmth. The cells react to the damage, and they undergo this process of inflammation. Now, this is actually a signaling process. The body is signaling something is wrong in that area. Not only that, but it's putting, as we're going to be discussing, out some signaling molecules called redox signaling molecules that are helping the body to detect and repair and replace the damage, and calling in the immune system too. And that's very important, because almost all problems that we might face, health problems, cancer for sure, injuries, stroke, cerebrovascular diseases, Alzheimer's, diabetes, etc., are all related to inflammation in different areas of our body and the cellular repair and replacement mechanisms. So if you get inflammation in your body, what happens often is that it'll build up reactive oxygen species. We can talk about what those are, but those are the redox signaling molecules. And I'm going to let you know a little bit, exactly what they are. But here's the inside of a blood vessel. This is the endothelium, and there's something happening down here that's causing inflammation and ROS. It's oxidizing the cholesterol, making it into oxidized cholesterol. It's also creating the signaling messages that are bringing the immune system in here. The oxidized cholesterol then is collecting in the immune cells and causing them to form plaques. It's also displacing things. So, and this is called atherosclerosis. It's a problem in heart disease. So inflammation, if it is not dealt with, it can be very bad for us. It can cause disease and problems. And redox signaling, by the way, is there to help to repair and replace these types of things. So, it used to be that oxidants were bad guys, and the antioxidants that we ate were the good guys, and so I'm going to look at, step back out and look at what these redox signaling molecules actually are. so that I can explain some of the science. Well, the new science is that we're starting to understand exactly how important these oxidants are in the signaling process. They're important in the signaling process in our nervous system. They're important in the signaling process in our cardiovascular system, in all systems of our body, in our lungs, everywhere. These redox signaling molecules are very important. And then the question is, okay, well, what are they? And actually, they're formed out of salt water. So some of you may have seen this before. If you take H2O and NaCl, which is a sodium salt, and NaCl and water, you can, we use an electrocatalytic process. And your body and the mitochondria also uses electrolytic process to be able to reduce them and oxidize them, to reform them into different types of molecules, like hydrogen peroxide and superoxides and hypochlorites and the such. Now, remember, these were the guys that used to be the bad guys. Now we're starting to understand that they now are the good guys. They are also the things that start to initiate inflammation in the body and start to signal that something is wrong in the body. Here is the concentrations and characterizations of the different molecules of ROS. And you can see that there are quite a few. And over here we see the labs that have done the work in relative concentrations and such of the different species. In the redox signaling molecules, or the redox signaling molecules and the redox signaling science, we study how these molecules interact with the different systems of the body and what they do. And let me just flip back to the other slide here. I might be giving you a little bit too much all at once here, but what these guys do inside the body is very important. You have antioxidants, which are produced by the cells, and oxidants, which are produced by the cells. And the oxidants help to detect and repair tissue. I'm going to give you one study that was done by the regeneration of tadpole tail. Here's a study for you, Amy. You know, the question was, how does oxidation affect, or what is the effect of oxidation on the regeneration of a tadpole? You can cut the tail off of one of these guys and it's regenerated. So if I cut the tail off and then look at the oxidation, which is in the red and yellows over here, you find that you have very high levels of oxidation as the cells are being regenerated. And in and around the areas where you have damage and you have regeneration, there's high levels of oxidation. These are the redox signaling molecules. These molecules actually are involved in the regeneration of the tadpole tail. And then when the tail is completely regenerated, the oxidation levels go down. So the question is, well, are these oxidants, are these signaling molecules actually very important in regeneration of tissue? And if they are so, then they are important in the process of healing and regeneration of tissue. In all the natural processes, they could have wide applications in medical science. So they put certain very powerful antioxidants in with the tail, the severed tail, and they realized that when the tail was severed and the oxidants were taken away, regeneration was not able to be complete. So we've realized that these redox signaling molecules are reactive oxygen species that I've showed you before, in the right combination, are responsible for the detection, repair, regeneration of tissues throughout the whole body, not only in animal life, but in plant life and every other form of life. So now the science of redox signaling basically is very universal and spread throughout all forms of life, all over the whole planet. And so The research that has been done in the last 10 years is starting to look at the different ways that these redox signaling processes work in our body.
All of the questions that we've been getting recently over the past week or so from people about, how do redox signaling molecules apply to my specific health challenge? I've heard you say before, Gary, that the question is, does the health challenge involve living cells? And if so, then yes. But more specifically, people's primary concerns these days are things like autism, gut and digestion issues, stroke, heart issues, autoimmune challenges of all kinds. I know we have someone in our family who had a kidney transplant a couple of years, and he's still taking some suppressant drugs to prevent the kidney that was transplanted from being rejected. And he's had great. He understands about redox signaling a little bit, but he's cautious about wanting to go off of all of the medications. And similarly, for a lot of people with COVID and particularly with long COVID, they continue to get some kinds of adverse health impacts from whatever infection they've had before. And I know a particular question which has been coming up the last couple of days is around dental health. So that's a large bunch of these sort of specific issues. I know you've dealt with, particularly with autism and really all of these things before. So if you could go into a little bit more specifics for us about the relationship between the redox signaling molecules and how our body can deal with these specific health challenges.
Yes, I have been very concerned about autism and diabetes specifically, in the sense that those two diseases or conditions, I should say, are increasing at an exponential rate, and we can expect to have very serious health issues from those areas. But you said that basically, what does redox signaling have to do with all of this, right?
Right.
And at the very beginning, you said, well, it has to do with a damaged cell of some sort. So, what causes diabetes, for example? And the answer is, well, the insulin producing cells inside the pancreas aren't working. They have died away. They are non-functional. They're damaged. And if the body could then be able to regenerate those cells, then they could come back into full function. And that's a redox signaling process. What about the cardiovascular problems that I mentioned before? If the body was able to reduce the oxidative stress inside of your cardiovascular system, then the body would be able to heal itself. And we're starting to understand now that these redox processes have a very wide and broad spectrum of effects in health. And let me share some research with you, if I can now. I've pulled these together. Here's some of the research that's been going on in redox signaling lately. Here's a real redox researcher, as Dr. Helmut Size. And he's a redox pioneer, and he's authored more than 5 articles that have received more than 1,000 references, which is incredible. He also has contributed to fundamental discovery of the physiology of glutathione. He's quantified central redox systems for energy metabolism. And then he's published more than 600 articles, 134, which are cited at least 100 times in 28 books. And then he has a high index of credibility. And he's known throughout the world. Many other scientists now are viewing these or are studying in depth these redox signaling processes, and here's what they're finding out. They're finding that, well, starting to realize, well, maybe cancer is a redox disease. Because cancer basically is when the cell has become so damaged that it can't even detect the damage any longer or repair or replace itself. And the only thing that it can do, if we're unlucky, is divide. And so the redox signaling system inside the cell, the whole network is shut down. And hopefully by rebooting that redox signaling network inside these cells, then the cells will be able to be detected, and the normal processes of the immune system and such will take care of them and destroy them. So here's another one. Redox chemistry of Alzheimer's disease in the amyloid B peptide, starting to realize that these redox signaling molecules or redox chemistry is very important for the disposal of these errant proteins inside your brain. And so that it helps to clear out the errant proteins and to prevent Alzheimer's and dementia and other problems that you might have. I mean, the research is very, very extensive. How about reactive oxygen and vascular oxidative stress and hypertension? And they're starting to realize that ROS is very important for regulating vascular health all throughout the whole body. A specific balance of these redox signaling molecules is required. It's called a homeostatic balance in order to be able to regulate vascular health throughout your whole body. Redox control of health and disease. Here's a beautiful review article that kind of covers everything. Redox regulation in disease and aging. The reason we age is the cells become damaged and are not able to repair themselves. And so the idea is if we increase redox efficiency, redox signaling efficiency, we may be able to repair and replace and regenerate tissue that has become damaged throughout the whole body. Here's the famous Watson article that says type 2 diabetes is a redox disease. And he goes on to show that imbalances of redox signaling molecules can be responsible for not just diabetes, but also dementia, cardiovascular disease, and then some cancers. And then time and time is going on, time over time, we're starting to realize more and more is involved in this redox signaling system. Now, for me, it's not a surprise, because having understood how these redox mechanisms work inside the cells, I know that when we increase the efficiency of these redox signaling mechanisms, the cells have more of a probability of healing themselves. And that's incredible. Have you ever seen X-Men where that guy Wolverine, and he heals faster than he can be damaged? And that's true. If we have these redox signaling mechanisms going in our body, we can heal the body faster than it's been able to degenerate and become damaged. Now, tell me, is this not a great medical technology? We also have insulin action as facilitated by reactive oxygen species with potential signaling targets. So we're finding out that when reactive oxygen species is in balance, is in homeostasis in the body, insulin also becomes more effective, and you need less of it. And so maybe this doesn't give you a very detailed view. You'd have to go through some of this research and understand some of the mechanics in order to get a detailed view. But I hope it gives you a great overview, Will, of what type of medical advances we might expect to see as our understanding of redox signaling advances.
how does this relate to people who are on immunosuppressant? It's not healing a cell which has been damaged, but it's suppressing your own immune system. How do people get off it, or how do you approach that?
That's very, sensitive subject, because of course you need your immune system in order to be able to heal, repair, and replace almost everything in the body. And these immune suppressants then are important when the immune system is overreacting to certain agents. So for example, as you mentioned, we have a kidney transplant and such. You don't want the immune system to overreact and rejection to take place. You have allergies or damage in your body that require that the immune system quiet down for a little while. The regulation of the immune system is very important. And what we want to have is that the cells that are damaged and that are under attack, those are detected more readily. The redox balance, or the redox signaling balance, helps the immune system to detect the cells that have been damaged. And so it makes the immune system more efficient, but not just more efficient. It's like giving your emergency responders radios that work very well, and maybe goggles that can see through the smoke. You get better communications with your emergency responders, and they have less of a chance of mistaking the signals, because often rejection of tissues and such are mistaken signals. It's saying that something that should be good is not good, and something that is good is not good, or something that's bad is good. By clearing up the signals, the whole immune system works much more efficiently. So in many cases, even in people that are forced to take immunosuppressants, the redox signaling messengers can be very effective, or are still effective in helping that process. Does that make sense?
So in this case, do you then be taking more of the redox signaling to counter what the suppressant is doing to the system?
The idea is to be able to just take normal amounts, is just to be able to help the immune system out a little bit in being able to communicate more effectively.
And continue.
Stop the bad signals, right? So just continue. The amount is a very touchy thing, as you probably can understand. But this is a science, so you can actually start with smaller amounts and see how it reacts. Very small amounts, if you wish. See how your body reacts, and then build it up. And generally, then if you do that, in fact, I've never seen any problems with people who have been careful and then built the amounts up over time.
Have you had cases of people getting off this kind of medications?
Oh, all the time. Yes. When the body heals itself, you no longer need the medications. There is a philosophy in medicine that I would like to address at this point. Many people say when you have damage, it cannot be healed. When you have diabetes, you can't get out of it. When you have different conditions, heart conditions, your body can't heal itself. If you have dementia, or you have brain issues, or even autism, so your body cannot heal itself. There can be nothing more wrong or erroneous than this feeling. Your body is built to heal itself. When it's given the correct things, your body can indeed heal itself. Your brain can heal itself. Your heart, your cardiovascular system can heal itself. It requires that the cells that are damaged are detected and either destroyed or repaired and replaced throughout your whole system. And please don't be ever dissuaded by someone that says, I'm sorry, you're going to have this for life. you can indeed try to get your body to heal itself by giving it the things that it needs. And that's the most important thing, above all. I say this actually from a perspective of someone who's seen thousands and thousands of people with very serious conditions, thousands, being able to recover full health. And they'd go to their doctors, and their doctors would say, well, that's really wonderful. They didn't ask what they do. They said, whatever you're doing, just keep on doing it. And so, medical science actually is a little bit behind in that sense.
Gary, that's wonderful. And it addresses a lot of questions, I think. I know there's also particular interest in what this does for the brain health and the mental side, both things like autism and just the anxiety. There seems to be a higher state of mental anxiety in a lot of people these days. So as similar processes, I'm sure, could you be a little bit more specific about what you've seen with that?
Well, yeah. What causes brain damage? What do you think?
Brain cells.
Yeah.
Brain cells that are injured, right?
Inflammation in the brain. It's called neuroinflammation. In autistic kids, there has been something triggered in the brain which causes chronic neuroinflammation. It's very painful. You know, these when they have an episode and their brains are becoming inflamed, they actually hit their head against something to try to relieve the pain. Neuroinflammation happens when the glial cells and the mast cells have an imbalance in there. There's a redox imbalance, actually. And they're sending signals to one another, and they go into a cycle of inflammation that is difficult to stop. This is true also for any type of brain injury, by the way, for dementia or whatever. Neuroinflammation normally is the brain's way of saying there's something wrong here. We need to fix it. And this is where redox signaling comes in. When redox signaling starts to become active in there, it activates the antioxidants. It takes away some of the oxidative stress that's in the brain, and allows the brain to realize where the damage is, the brain cells. This is the same story over and over again. The brain cells realize where the damage is. They go in, they fix the damage, they undo the oxidation or get rid of the oxidants, and then the brain is able to undergo its natural regenerative effect, or it's neuroplastic too, so they can start to form new connections and relations and make up for the brain damage that has already taken place. And this is a slow process. It's a little bit slower with the neurons because the neurons do not regenerate as fast as the soft tissue of the lungs, the heart, the kidney, liver, etc.
Aside from all the published literature, peer-reviewed scientific literature, there are a number of popular books coming out. I think you may have seen this one Disease, Redox Imbalance. And it's written by a fellow named Michael Scherer, who I believe is not a biochemist or even a researcher himself, but he had gone through a lot of literature, and he came to the conclusion simply that, as you were suggesting earlier, that disease is caused by inflammation, and inflammation is caused by stress. But and I want to come back to that point, but he says one other thing, which I hear all the time from people when we're talking about redox signaling molecules, and he asks the question, how can it be that scientists already broadly recognize that oxidative stress and redox imbalance play a leading role in cancer, heart disease, diabetes, aging, depression, dementia, and virtually every other disease in humans, animals, and even plants. But my doctor has never mentioned anything about it. Yeah. So if you could address that a little bit, as well as if you agree that it's really that simple, that there really is one kind of unifying disease that we have to deal with, and it's caused by stress, which leads to inflammation.
All right. Well, what have we been saying right now? That inflammation is a signaling process. It creates oxidative stress and oxidants inside the cells, whose job is to stimulate repair and replacement of cells. So wherever there is, whether it be cancer or any type of element that you had mentioned, there is inflammation. So, even in that book, I think he had it a little bit backwards. He still is not quite grasping that inflammation is not a bad thing. That as long as it leads to healing, repair and replacement of cells, it's a good thing. And I've said in my blog, is pain bad? Is oxidative stress causes pain? And the answer is, well, it depends. If the body's not able to correct itself, then this chronic pain can be bad. But the pain itself is an indicator that something is wrong in the body. So is the oxidative stress. And then this stimulates the genes that are necessary to repair and replace the tissue that has been damaged. So that's really kind of where we're going here. If we were to really leverage all that we know in science now, I think we're about 15 years behind, maybe 20 years behind in our medical practice versus our scientific knowledge of how we can deal with disease and with problems, with all sorts of health problems. And the reason is that the development cycles are very inefficient. It takes $1 billion to develop a medication that's accepted, and such. And the price tag is very heavy. It takes a long time to patent and find substances that are patentable. The redox signaling molecules are not patentable, so we can't make medications out of them. Who would spend $1 billion, for example, even on a technology that works, if they weren't able to get a return? And so it becomes a very difficult problem. Now, I have great faith that the medical system, actually, just like the IT system and all technologies that we've seen explode, will start to take on the idea that what works really wins. And then we'll start to get research in redox signaling. We'll start to get research in stem cell technologies. Because I got research in how to reverse autism, how to do all of these things, and that is very exciting to me. In fact, I hope I live to see it. Wow. I hope I live to see the time when we can go in and people will be competing to find the cure or to resolve health problems, and that would be a wonderful time. I kind of stopped when I was talking about oxidants and antioxidants. And these oxidants over here that are produced by the body are hydrogen peroxide, superoxide, hypochlorites, and oxygen free radicals. How in the world does that relate to salt water? Okay, so there's one question in there. What in the world relates to salt water? Inside of all of our cells and all of our body, we have salt water. And these reduction and oxidation processes turn the salt water into this reactive oxygen species. It oxidizes and reduces the salt water. It changes their form so they become hydrogen peroxide, superoxides, hypochlorites, and oxygen free radicals. That transformation that we do inside the laboratory is done in an electrocatalytic reactor that takes the salt water and then turns it into the same substances that are produced by our mitochondria. And this is our mitochondria, basically, that is producing these oxidants. And they're also producing electron donors, which is NADPH and such. that together with the antioxidants eliminate the oxidants. So you see that this cell is in a homeostatic balance. When the cell is damaged, then the mitochondria starts to build up more of these oxidants. It's like building up the smoke inside a fire that is not burning correctly. Your mitochondria, by the way, is your energy producing organelle. It's not producing energy correctly. It produces smoke, free radicals, oxidants, and such. And this is called oxidative stress. This is what causes swelling and what causes inflammation, what starts the signaling process to say something is wrong here. And that process then is what matters. Now, what helps the cell to repair and replace itself. Now, I have a bunch of stuff here. let's see. We can go back, I believe, here, and I'll give you an example of how this works. So, in this picture, we are seeing living cells, and on this side, they've been damaged by oxidants. Well, I mean by X-rays, I'm sorry, and the oxidants are building up, and you can see this because green is the indicator now of oxidative stress. So in here, they're redox signaling molecules. Well, the signaling molecules, instead of being bad, actually they're good because they're the molecules that allow the immune system to react. The immune system then comes in and also uses the same oxidants to kill the bacteria, the viruses, everything. By normal cellular division. Now, these oxidants that we're looking at in green, they're not salt water. And nor is the compounds that I've made in the laboratory. That it's not salt water. They are actually these oxidants, redox signaling compounds, in such a combination and balance that they are signaling the body to help repair and replace itself more efficiently. What we can do is give our body the best chance of healing itself. And by the way, redox signaling molecules are not the only things that can help us to heal, for the body to heal itself. Often the therapies, the very therapies that we use to try to destroy the cancer, also destroy the immune system, which helps to detect, repair, and replace and destroy the cancer itself. And it weakens the body. And in fact, if the body becomes too weak, then we have to be careful. When redox signaling starts to take place, it cleans house. It helps our body clean house. And I wanted to mention this because now we're moving on to other areas that we need to be concerned about. When the body starts to clean house, what does it do? What do? You take all of the garbage and you throw it out in the street. So things become worse before they become better. Now, while the body is cleaning house, it's opening up these redox channels and the detoxification channels in the body. And there's a protein there called drug-resistant protein. The drug-resistant protein is there because basically it resists, it throws out all the garbage, even throws out the drugs. So the body tries to detox itself from drugs, and then the pharmacy industry doesn't like that. Like they have to get past these drug-resistant or multi-drug resistant proteins. And so actually redox activates these and helps to pull out the toxins and the garbage, which is usually a very good thing, unless your kidneys are not working, the digestive system is not working. You have what they call leaky gut, and the body, and also inflamed intestines. So what do we need to do? We actually need to heal the gut first. Also, hydrate the body because it requires a lot of water through our cardiovascular system to pull the garbage out of our tissues and get them released. It also makes us a little bit sick So people that have large scale damage in their body, they start to take the redox and they feel flu-like symptoms. They feel weak. That's because their immune system and all the other systems are kicking in. They're cleaning house. It takes energy to clean house. And so there are other things that are needed. When we start understanding these things, we realize that in order to be able to gain optimal health, sometimes we need a coach. And a coach is a person not only that has the knowledge that can teach us why, you know, but we also can kind of take us by the hand. I mean, how many of us know that we should exercise daily? And then the question is, you know, how many of us do exercise daily? And if we know it's so good for us, and we know that it can actually help to give us optimal health, why don't we do it? And that's a question. So I realized that actually the coaching, the choices that we have to make are very important. They're our most important part. So if we have a coach on a team, you know, the coach will help us to realize what we need to do in order to become our best self. And then we are responsible to put that into action and to do that in order to become our best self. And so I realized that, you know, some very simple laws, by the way, that are known, let's see, are actually responsible for about 80% of the health problems that we have. I'm having a hard time getting this up here. Oh, there we go. And these are the principles. I call them the 5 laws of physical health. And basically, they're the things that the cells require. The cells require water. What kind of water? Well, actually, they need electrolytic water and certain types of water that are easily absorbed. I call it natural water because it's the water that's in the streams and the rivers. Nutrition, vital nutrients. You know, where do we find those? Exercise, I mentioned before, sleep and respiration. Now these things are actually the laws of physical health. And if we don't do these things, nothing else really works because the cells don't have the materials and supplies that they need in order to work, actually. So let me go back down to dehydration. In the United States, because we eat a lot of pizza and bread and medications, laxatives, steroids and such, it pulls the water out of our body and makes us slightly dehydrated. And I'm talking slightly, only about 2%. Nearly 75% of everybody in the United States, it's estimated, is suffering from dehydration. If you have even slight dehydration, you have 22% more chance of a heart attack. You have a chance of Alzheimer's, diabetes, acid reflux, arthritis, constipation, moodiness. Also, when you take your Redox, you don't have enough flow of the fluids in your body to get the toxins out, to get the organs moving. You gain weight, you become depressed, you get headaches, bad moods, and all of this, and you even can feel hungry. And really, all you really need to do is hydrate yourself. So I put a pinch of salt and some lemon juice in this water to make it electrolytic water, and then drink at least 2 liters of it a day. And so skin problems, cramps, stiffness, high blood pressure, inflexibility in your joints, pain, and all of these things actually can be caused by lack of water. And now, what kind of technology are we talking about? It's the most fundamental technology of life. You know, when we become sick, they stick an IV inside of us and inject salt water, in this electrolytic water, into us, and it helps greatly. So anyway, also nutrition. nutrition. Now, how many of us know what we should eat? Do we know what our perfect diet is? Here we go again. And now you got me going, so I'm sorry. I say these things because I know and truly, and the science has shown that truly, if we are able to supply our body with the micronutrients that we need, and there are only about 40 of them, 40 micronutrients on the molecular level that are in our foods. If we supply our body with these 40 micronutrients, then they will be it. Well, you don't need to know what they are, I listed a few of them here: beta carotene, lycopene, vitamins, folates, etc. But what you do need to know is that they're found in living plants and foods. And the different colors of the foods indicate the type of micronutrients that are there. In your last meal, what was the color on your plate? Was it mostly white and brown, which are your proteins and carbs? Or did you have red, yellow, purple, orange, green? And so what was, these things? Bruce Ames, a famous nutritional giant, said this. He has been studying nutritional deficiencies among people. And here is a list of the 40 essential micronutrients. Bruce Ames will actually go down one by one on these things and tell you what will happen if you're deficient in any one of these. Some of these, like choline, will cause permanent damage in your body. But he has what they call a triage theory. And this is how the body reacts to micronutrient deficiencies. When there are not enough micronutrients in the body believes that it is starving to death, literally, because it can't get enough supplies in order to give the cells what they need. This hunger status activates the preservation mechanisms. It makes you hungry too. So you eat more carbs, you eat more, of the proteins and amino acids, and you don't eat the salads and the greens, yellows, oranges, purples, etc. You get fat. Your body starts to switch from modes that will help you to preserve your health to disregard a healthy future, and it switches over to starvation mode. Basically, it converts the sugars into fats. It does a lot of things that it has to do because it feels like we're starving to death. We're not really starving to death. We just don't have enough micronutrients. How you get out of that is simply to eat the micronutrients that you need. Have half a plate of salad and learn how to make them so that they're very delicious. So what happens when you do a half a plate of salad is that not only do you get the micronutrients that your body needs, the vitamins A, B, D, C, and all of the vitamins and minerals that you need, as well as, like DHA and other such micronutrients in there. Not only do you get that, but that your body starts to realize, hey, I am in a healthy, abundant state. And then your body will start to repair your cardiovascular system. It'll start to start these repair and replacement processes that is kind of put off for a while because it was in emergency mode. And you start feeling great. In fact, when I started doing this, I actually craved vegetables. When I got hungry, I'd go out and I'd get some raw salads, and I started eating the raw salads. And it wasn't that I was torturing myself. It was that I really enjoy this, and that my nuts and everything else. I really enjoyed it. And along with the technologies that I know, if we just supply the cells with the basics, and that is, so I've actually seen more results through coaching, one-on-one, heart-to-heart coaching in improving health than I have actually by just developing technologies. And I don't know if you know me, but that's what drives me. I want to be able to do things that help people gain their optimal health and reduce suffering in the world. So, you know, this is why I did this. And I think that's also the answer.
Gary, you know, I think you've just given everyone a good taste of what your cellular health coaching is all about. And having gone through the Essentials course myself a couple of years ago, I strongly recommend it to everyone. We're really kind of at the end of this hour, and I think everyone both appreciates and has a sense of a better sense now of what you've been doing and how this all relates to our own health and where we can go in the future. But could you just maybe give us sort of the access? What's the best way for people to learn more about your cellular health coaching and to your blog and how people can keep up with you going ahead in the future? And if you have any final comments about how redox signaling molecules fit into the 5 laws of health, of good health, and what you would like to leave us with this evening, I think this has been wonderful. Thank you.
Thank you. Everything I've talked about is interrelated tonight. It's how do we get ourselves the tools, the supplies, and materials that they need in order to be able to function correctly. Not only on a physical level, but on an emotional, mental level also. How do we do that? If you're interested in learning more, in my mind, we can actually replace most 80% of our medical system, except for those emergency cases. And the suffering that we have in the world by simply getting this knowledge out there. Not only getting the knowledge out there, but motivating people to act on that knowledge. So this is what we can go to. If you're interested, Dr. Gary Samuelson, drgarysamuelson.com. There's also cellularhealthcoaching.com, and you can look up those things. We put out videos. In fact, I'm thinking of releasing right now a micro course in these things that'll be accessible to everyone. So I appreciate this very, very much. If we are able to build the lifeboats, by the way, build the lifeboats, when we see people struggling and we know how to do that, we can pull people in to these lifeboats. And there are a lot of people struggling right now, and there will be in the future.